वेलकम टू वीएसबी ब्लूप्रिंट गाइस। आज डे 3 है। लोग कहते हैं कि शुरुआत करना मुश्किल होता है, लेकिन सच तो यह है कि शुरुआत के बाद लगातार चलते रहना सबसे मुश्किल होता है। अगर आप आज भी यहाँ है तो आप उन लोगों में से है जो लोग सिर्फ सपने देखते नहीं, उन्हें पूरा करने की तैयारी भी करते हैं। चलो दोस्तों, आज का पहला सेशन शुरू करते हैं। Subject soil mechanics, chapter number 7, sewage. Flow line म्हणजे काय? It is a line along which flow takes place. Flow lines also referred as a path line because it represents the path traveled by a water. In the case of gravity dam, flow line passes through its foundation, whereas in the case of earthen dam, flow line passes through its body. Next term is equipotential line. Equipotential line is the line indicating point of equal potential head. All points are equipotential line has a same amount of energy. When water flow from upstream to downstream, there is a condition loss of a head due to the resistance offered by a soil to the flow of the water. Equipotential line, it is the line indicating point of equal potential head. All points on equipotential line has the same amount of energy. However, when a water flow from upstream to downstream, there is a continuous head loss due to the resistance offered by the soil to the flow of a water. Next term is a flow channel. It is the space between the two adjacent flow lines, and it represented the total flow path between the two flow lines. It's called as flow channel. The number of channel, the formula आहे the number of flow minus 1, the number of flow line minus 1. Number of channel is equal to the number of flow line minus 1. Flow channel म्हणजे काय? It is the space between the two adjacent flow line, and it represents the total flow path between the two flow lines. Next term is a flow field. Flow field is the space between the two adjacent flow line and two equipotential line. It is the space between two adjacent flow line and two equipotential line. The shape of flow field is a rectangle, but for the purpose of design we consider it as a square. Next term is flow net. It is the net formed due to the combination of number of flow lines and equipotential line. Flow net is the net formed due to combination of number of flow lines and equipotential line. In the case of gravity dam, flow net form in a foundation, whereas in the case of earthen dam, flow net form in a body. Following are the application of flow net. Flow net ची application: to find the seepage and head loss, to find the seepage and pressure, to find the applet pressure, to find the exit gradient. Seepage loss rate काढासाठी seepage प्रेशर काढायसाठी, अपलिफ्ट प्रेशर काढायसाठी आणि एक्झिट ग्रेडियंट काढायसाठी. कॅरेक्टरिस्टिक्स ऑफ फ्लो नेट and equipotential line are orthogonal to each other, means perpendicular to each other. Flow lines and equipotential lines are orthogonal to each other. Discharge passing through each flow channel is constant. Discharge passing through each flow channel is constant. Potential drop in two equipotential line is constant. Potential drop in between two equipotential line is constant. That is delta H1 is equal to delta H2 is equal to delta H, and delta H चा फॉर्म्युला आहे H/ND. H/capital N into small d. All points on equipotential line represented the same height. The shape of flow field is approximate as a square. The net made up of series of curved line. Flow net made up of series of curved line. Flow line and equipotential line do not start from the same point. Seepage loss rate SLR. Seepage loss rate ला शॉर्ट फॉर्म मध्ये SLR म्हणतात. For calculating the seepage loss rate to each flow channel, following expression is used. Q is equal to small q is equal to K into capital H into capital NF upon capital ND. capital seepage loss रेटचा फॉर्म्युला आहे SLR. त्यालाच आपण स्मॉल k म्हणतो. K into H into capital F NF upon capital N small d. K is equal to permeability of soil small k. Permeability of soil, CDH is a total heat loss. channel whose formula is flow lines minus 1. ND is equal to number of drop कसे काढायचे तर इक्विपोटेन्शियल लाईन मायनस 1. नंबर ऑफ फ्लो चॅनल कसे काढायचे दोन लाईनच्या मध्ये एक चॅनल आहे फ्लो लाईन मायनस 1 ND number of drops TL minus 1 and FL minus 1 is equal to head loss. Total head loss कसा काढायचा total head loss काढायचा height of upstream minus height of downstream HUS upon H DS downstream seepage loss rate in each channel is equal to slippage loss rate in each channel काढायचा असन त्याचा फॉर्म्युला आहे स्मॉल k इंटू कॅपिटल H इंटू 1/ND आणि NF ची व्हॅल्यू एक घ्यावी लागते SLR in each channel is equal to small k into H upon ND. SLR in each channel is equal to k into H upon 1 ND. H into 1 upon ND. H upon 1 upon ND is equal to H upon ND. Next topic is seepage pressure. Seepage pressure म्हणजे काय तर seepage pressure is the pressure exerted by the seepage of water on a soil particle. Seepage pressure is the pressure exerted by a seepage of water on a soil particle. That means seepage pressure act in a direction of seepage water. Seepage pressure act in the to calculate the seepage pressure use a total head loss as H. Use total head loss as H because the seepage is occurred due to the difference between the head. Seepage pressure P shape capital P suffix shape gamma W H small h the head remains up to that point. Capital H minus head loss up to that point. Seepage pressure is equal to gamma W small h value is capital H minus head loss up to that point. The gamma W into capital H minus head loss up to that point. Okay? pressure is equal to gamma W small h value आहे capital H minus head loss up to that point. Next term is applied pressure. Applied pressure, it is a pressure exerted by a soil in the upward direction to uplift the structure. The direction of applied pressure is in the upward direction. Applied pressure Pu is equal to gamma WH. Applied pressure is equal to Pu is equal to gamma WH. We considered water level on a downstream as a reference. We consider water level on the downstream as a reference data and hence to find pressure. Use entire water storage on upstream. Consider entire water storage on upstream side is executed in this term represented the head loss per unit length of flow at exit point of flow net. Next term is exit gradient. Exit gradient represents head loss per unit length of flow at the exit point of flow net. I exit is equal to the head loss divided by length. So delta H म्हणजे head loss and length. I exit is equal to delta capital H upon delta capital L, where is delta H is equal to capital H upon ND, means I exit is equal to the H upon ND divided by delta L, where delta L is equal to the average length of last flow field. Next, concept of effective stress due to the seepage. तीन प्रकारचे इफेक्टिव्ह स्ट्रेस ड्यू टू द सीपेज आहे. नो सीपेज, डाउनवर्ड सीपेज, अपवर्ड सीपेज. नो सीपेजले सिग्मा डॅश इज इक्वल टू द गॅमा डॅश इंटू झेड. झेड इज द Seepage calculated the depth of soil up to that point. Where the seepage is calculated, yes means seepage head given in the question. Seepage म्हणजे sigma dash is equal to gamma dash into capital Z. डाउनवर्ड सीपेज म्हणजे खाली चालला तो डाउनवर्ड सीपेजचा फॉर्म्युला आहे sigma dash is equal to the gamma dash z plus gamma whs. Seepage loss hs means seepage head. Sigma dash is equal to the gamma dash z plus gamma w into hs. Sigma 1 into z plus gamma whs. Seepage hs means seepage head in the question. The third one is upward seepage. Third one is upward seepage. Soil चा तर खाली जाईल आणि वरतीच आहे. मग काय झालं sigma dash is equal to the gamma dash z minus gamma whs. Where stress due to soil, that means gamma dash z become equal to the stress due to water, that is gamma whs. Then effective stress sigma dash on a soil particle is 0, and this condition is called as a boiling condition of a soil, which is highly undesirable. When the stress due to the soil, that means gamma dash z is equal to a stress of water, that means gamma whs. Then the effective stress sigma dash on a soil particle becomes 0, and this condition is called as a boiling condition of a soil, which is highly undesirable. For a maximum or critical condition, gamma dash z is equal to the gamma whs. Gamma dash z is equal to the gamma whs, means gamma dash upon gamma w is equal to the hs upon z. Critical gradient काळाचा असा. Critical gradient is denoted by small I suffix c is equal to the gamma dash upon gamma w, where is gamma dash is equal to the hs minus upon z into gamma w. और gamma dash चा फॉर्म्युला आहे gamma w g minus 1 upon 1 plus e. Gamma dash is equal to gamma w g minus 1 upon 1 plus e. And gamma w, this is gamma w cancel, then ic is equal to the g minus 1 upon 1 plus e. Critical gradient ic is equal to the g minus 1 upon 1 plus e. Critical gradient ic is equal to the g minus 1 plus e. Factor of safety against the piping is given by. The factor of safety against piping is given by critical gradient upon exit gradient. ic upon I exit. Factor of safety is equal to ic upon I exit. That means strength upon actual stress. In safe condition, factor of safety ची value काय आहे तर ic is greater than I exit. Safe condition. That means factor of safety is greater than 1. In safe condition, factor of safety is greater than 1 and ic is greater than I exit. When critical condition occur, ic is equal to the I exit and factor of safety becomes 1. And in unsafe condition, critical gradient is less than exit gradient and factor of safety is less than 1. When in that condition piping कधी ऑफर होते जेव्हा critical gradient is less than exit gradient or factor of safety ची value less than 1 तेव्हा piping ऑफर होते त्याला unsafe condition असं म्हणतात. Seepage pressure PS is equal to gamma WH and gamma WH small h ची value लिहिली आहे small I into Z. Heat loss चा फॉर्म्युला आहे I is equal to म्हणजे gradient is equal to heat loss upon depth Z. मग H is equal to झाला IZ. मग gamma W H च्या जागी टाका IZ. मग gamma W IZ is equal to the PS. PS म्हणजे seepage pressure is a modified formula. Seepage pressure PS is equal to gamma W IZ. Seepage force F. Seepage force F is equal to the seepage force F PS into E. PS means gamma W. Depth into area and becomes volume. The gamma W IV is F is equal to gamma W IV. Next term is the piping. Piping is the phenomenon of erosion of a soil particle from the downstream base of a structure, and its erosion continue toward the upstream side and cause a pipe-like structure. This is called a piping. Piping is also known as undermining. The phenomenon is observed in a fine and silty sand which can be easily eroded. Following care to be prevented the piping under the structure. Increase the base width of a dam. Provide a sheet piling at downstream side. Provide inverted filter at a downstream end. Increase the seepage length. Increase base width, increase seepage length, provide a sheet piling at the downstream end, and provide an inverted filter at the downstream end. Next term is a quicksand condition. This condition also refers as the boiling condition of a soil particle. It is occur in the case of silt and fine sand, where the value of cohesion is 0. When gamma dash z is equal to gamma WHS means critical condition, then effective stress sigma dash is equal to 0, and for silt and sand tau shear strength is equal to the sigma dash tan phi, where C is equal to 0, then tau is equal to when gamma dash z is equal to the gamma WHS, then sigma dash is equal to 0, and for silt and sand condition, the tau is equal to the gamma dash tan phi, where C is equal to 0, then tau is equal to 0. Tau 0 represented the soil behaving like a liquid, and due to equal amount of upward and downward force, soil particles remain in a floating stage, and such a condition is referred as a boiling condition. When shear strength tau is equal to 0, it represents soil behaving like a liquid, and due to equal amount of upward and downward forces, the soil particles remain in a floating condition, and such a condition is referred as a boiling condition. Boiling condition cannot occur in a clay due to the presence of cohesion. Boiling condition is not possible in a gravel or a coarse sand, as the permeability of soil is high. आता सिल्ट अँड सँडमध्येच बॉइलिंग कंडिशन वापर होते. टू प्रिव्हेंट द बॉइलिंग कंडिशन, apply some surcharge weight on the top of soil and reduce the level of groundwater table. Next term is earthen dam. Major reason behind the failure of earthen dam overtopping of water. It is the major reason of failure of earthen dam. Low net present in the body of earthen dam. Upstream inclined face of dam represent the equipotential line. Upstream inclined face of earthen dam represent the equipotential line. Topmost flow line in earthen dam is a phreatic line. Topmost flow line in a earthen dam body is a phreatic line. Phreatic line is parabolic. Below phreatic line there is a presence of water, and over the phreatic line there is no presence of water. Phreatic line represents the top boundary of flow net. Phreatic line is the top boundary of flow net. The shape of phreatic line is parabolic. The shape of phreatic line is parabolic. Shape of phreatic line is a parabolic. Phreatic line represents the boundary of a flow net. Below phreatic line there is a presence of water, and above the phreatic line no water is present. The most flow line in the topmost flow. Estimate the seepage loss rate. Flow net is constructed, and enough from the number of flow channel and ND is equal to 7, and use the coefficient of permeability. K is 5 into 10 to the power 5 meter per minute, and total heat loss H during the seepage is 6 meter. Find the SLR in meter cube per day per meter. Given data NF is equal to 7, ND दिला है 17, K दिला है 5 into 10 power 5, and H is 6. To find SLR meter cube per day per meter मध्ये काढावं लागते. मीटर पर मिनिट म्हणजे मीटर इंटू 60 सेकंड इंटू 24 आवर, याला मीटर पर डे. Seepage loss rate SLR means small q is equal to k into h into nf upon nd. Q is equal to kh nf upon nd. K is equal to 1 y in the system to minus power 4. Permeability of soil in a horizontal direction is, and vertical direction is. The reservoir is full and the height is 30 meter. Use NF is equal to 4 and ND is equal to 16. Find SLR in liter per second. KX दिला है, KY दिला है. 1 meter cube is equal to 1000 liter. 1 meter is equal to 1000 mm, and per meter K equivalent is equal to under root of kx into ky. K equivalent is equal to K equivalent is equal to काय ते kx into ky under root kx into ky under root kx into ky. SLRQ is equal to K into H into NF by ND. So 1.5 meter length of the soil subjected to the upward seepage head. 1.9 meter. What depth of sand required above top of present soil to attain the factor of safety 1.5 against the piping whose G specific gravity is equal to 2.67 and N means porosity 0.3 factor of safety 1.5 G दिला है 2.67 N दिला है 0.3 and H दिला है 1.9 meter. The factor of safety is equal to IC upon I exit critical gradient upon exit gradient. IC is equal to the formula is G minus 1 upon 1 plus E. G minus 1 upon 1 plus E. But why don't know the E? E कसा word ratio काढायचा N upon 1 minus N is equal to 0.3 upon 1 minus 0.3 is equal to 0.428. आता I exit limit I exit चा फॉर्म्युला H by Z. H दिला आहे 1.95 Z किती दिला आहे 1.5 plus 1.95. The depth of sand required above the top of present soil to attain the factor of safety is 1.002 meter. Exit gradient I exit is equal to the delta capital H upon delta capital L. Delta capital H is equal to the H upon ND. To find height of dam, use exit gradient 0.7. Consider the water flowing from the dam. Water is flowing from the dam means height of dam is equal to the height of upstream. The I exit is equal to H upon ND divided by delta L, and H is equal to HUS minus HDS upon ND upon delta L. Concept of total stress sigma dash for water pressure WP means P. Effective stress sigma dash total stress sigma is equal to total stress with the stress due to the self-weight of a soil and water. Gamma sat is used to find out the total stress sigma. Sigma is equal to gamma sat HS. Total stress is the stress due to self-weight of soil. Total stress sigma is equal to gamma sat HS. Total stress sigma is equal to gamma sat HS. For water pressure, PWP means mu. It represents It represents is due to the presence of water. mu is equal to gamma WHW. For water pressure, mu is equal to the gamma WHW. PWP mu is equal to the gamma W into HW. Total stress sigma is equal to gamma at HS. Now effective stress sigma dash is equal to the sigma dash जर काढायचा असेल तर sigma minus for water pressure काढून टाकायचा. The effective stress is concerned with the stress due to the soil particle only. As for water pressure increases, the effective stress decreases. To find out the sigma dash, we at a point P. Okay. Gamma dash is equal to gamma set minus gamma W. Gamma dash is equal to gamma set minus gamma W. Where effective total stress at Q काढायचा आहे तर gamma DH1 एवढाच. Capillary consideration in a stage diagram. In some cases, the water rises in a soil mass in upward direction through the voids of the soil, and this phenomenon of rising the water is known as a capillary. Water in the capillary zone is under a tension. Water in the capillary zone is under the tension. Maximum tension is represented at point which is farthest from water table level. Maximum tension is represented at point which is farthest from the water table level. Pore water pressure at water table is 0. PWP at water table is 0. Draw pressure diagram for a soil profile is given below, and it is observed that the water rise 1 meter above the ground level table due to the capillary. Okay. ग्राउंड लेवलच्या खाली गॅमा डी दिलेला आहे 16, त्याची हाईट दिली आहे 1 मीटर. त्याच्या खाली दिलेला आहे गॅमा सॅट 20, त्याची हाईट दिली आहे 1 मीटर. आणि त्याच्या खाली दिलेला आहे गॅमा सॅट गॅमा डब्ल्यू, त्याची हाईट दिली आहे 3 मीटर. तर पॉईंट ए बी सी सिग्मा काढायचा गॅमा डी H1 पॉईंट ए गॅमा डी H इज इक्वल टू 0. पॉईंट बी वर काढायचा गॅमा डी H1 16 × 1. तर सी वर काढायचा आहे गॅमा डी H1 प्लस गॅमा सॅट H2. आणि डी वर काढायचा आहे गॅमा डी H1 प्लस गॅमा सॅट H2 प्लस गॅमा सॅट H3. Next chapter number 8 is permeability, lecture number 15. The meaning of permeability is the ability of soil mass to permit the flow of water through it. The permeability is also called as hydraulic conductivity. The ability permeability is designated by a symbol K letter and expressed in a unit of velocity. When water is flow through the soil mass, then two types of velocity is expressed as follows. First one is a true oblique actual oblique seepage velocity. The velocity is calculated by considering the area of voids is called as the actual, true or seepage velocity. It is denoted by Vs, and the formula for Vs is equal to the capital Q upon A voids. Second one is the imaginary or discharge or total velocity. The velocity is calculated by considering the entire area of the soil mass. Entire area of soil mass V is equal to Q upon A soil. दोन velocity आहे. ॲक्च्युअल velocity त्यालाच आपण ट्रू velocity म्हणतो, त्यालाच आपण सीपेज velocity म्हणतो. It is denoted by Vs, and formula for Vs is equal to the Q upon A voids. Imaginary discharge or total velocity. Total velocity कशी काढायची, तर V is equal to capital V is equal to capital Q upon area of soil, entire area of soil mass. Vs is equal to capital Q upon A voids, or total velocity means discharge velocity किंवा imaginary velocity capital V is equal to Q upon A soil. Q upon A soil. Q upon A soil. Next topic is Darcy's law. The concept of permeability and its study is proposed by Darcy. As per the Darcy equation, the total velocity is directly proportional to the hydraulic gradient. V is directly proportional to the hydraulic gradient small I. To eliminate the sign of proportionality, eliminate the constant V is equal to the Ki. V is equal to Ki. Darcy's law: V is directly proportional to the I and P is equal to Ki. V is equal to the Ki. V is equal to the K into I, where a K is a coefficient of permeability or simply permeability, and I is equal to H by L. I is equal to small h upon capital L, where H is equal, where H means head loss and L is length of flow. V is equal to the total velocity, that means Q by area, discharge upon area. V is equal to Q upon E. Q is equal to V into E. Discharge is equal to velocity into area. So V is equal to K into I. So put in V is equal to Q by A झाला ना. So V च्या जागी K I डिवायडेड I इकडे केल्यावर मल्टिप्लाइड बाय, तर मग डिस्चार्जचा फॉर्म्युला झाला discharge Q is equal to K small I into capital A. Discharge is equal to Kia and V is equal to K. V is equal to K, Q is equal to V into area. I is equal to H upon L, head loss upon length of flow. Okay. Cauchy's-Karman equation of permeability. Next topic is Cauchy's-Karman equation of permeability. K is equal to d10 square upon 1 by C E cube upon 1 plus E into gamma W mu. Cauchy's-Karman equation of permeability. K. Cauchy's-Karman equation of permeability. K is equal to d10 square into 1 by 6 into e to the power 3 upon 1 plus e into gamma W mu. K is equal to d10 square 1 by 6 e cube upon 1 plus e upon gamma W mu. K is equal to d10 square into 1 by 6 1 by c into e cube upon 1 plus e into gamma W divided by mu. K is equal to d10 square into 1 by c into e cube upon 1 plus e into gamma W divided by mu. And this formula is equal to K is equal to K naught into gamma W mu. म्हणजे K naught चा फॉर्म्युला होईल d10 square into 1 by IC into e cube upon 1 plus e. The permeability based on a property of soil and water flowing through it. Permeability based on the property of soil वर बेस आहे and water जसं फ्लो होते त्याच्यावर बेस आहे. Gamma W and mu is the property of water. Gamma W and for water pressure mu is the property of water. and D10, C and E is the property of soil. K is the permeability of soil. D10 is the effective size of a soil grain. D10 is the effective size of soil grain. C is the constant of soil. Gamma W is equal to the weight density of soil. Gamma W weight density of soil. Gamma W is equal to weight density of soil. Mu is equal to dynamic viscosity of water. 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 Gamma W. Mu is the property of water. Water J dynamic viscosity. Dynamic viscosity of water. Gamma W is equal to weight density of water. C is equal to constant of soil. D10 is equal to effective size of soil grain. K is equal to permeability of soil. Cauchy-Skarman equation KCE. Cauchy-Skarman equation of permeability KCEP. Cauchy-Skarman equation of permeability K is equal to D10 square into 1 by C E cube upon 1 plus E into gamma W mu. K is equal to D10 square into 1 by C into E cube upon 1 plus E into gamma W divided by mu. K is equal to D10 square into 1 by C into E cube upon 1 plus E into gamma W upon mu. Following relation can be worked out from the above equation. K is directly proportional to the D10 square. K is directly proportional to the E cube upon 1 plus E. K is directly proportional to the gamma W, and K is inversely proportional to the 1 upon mu. Means permeability is dynamic viscosity of water. K is inversely proportional to the dynamic viscosity of water mu. Following factor affect the permeability: size of soil grain, void ratio E, weight density of water gamma W, dynamic viscosity of water mu, shape of soil particle. कसं तर permeability of rounded particle is more than permeability of angular particle. Temperature T, absorb water, air, voids, organic matter, and degree of saturation of soil. Yes, sir. Equivalent or average permeability when flow is parallel to the layer of soil. Equivalent or average permeability when flow is parallel to the layer of soil. Let us consider the three layer of soil thickness H1, H2, H3 and permeability K1, K2, K3 respectively, and Q1, Q2, Q3 represented the water flowing through each layer, and Q is the total discharge of water. The value of head loss is constant for all the layer, and the length of each layer is the same. Therefore, I is equal to the I1, I2, I3. Total discharge Q is equal to Q1 plus Q2 plus Q3. A average is equal A average into I into capital A is equal to K1 I1 A1 plus K2 I2 A2 plus K3 I3 A3, as head loss and L is the same. Head loss is the same, so I is same for all. The I1 is equal to H1 upon capital L1. The hydraulic gradient is same for all, means I2 is equal to H1 L2, I3 is equal to H3 L3, I is equal to H upon L. Equivalent or average permeability when flow is parallel to the soil. K average the formula है K1 H1 plus K2 H2 plus K3 H3 upon summation of H, means H1 plus H2 plus H3. Average permeability in the case of layer of soil when the water is perpendicular to the when water flow perpendicular layer, that means in a vertical direction. The area of flow at the same for all layer. Area of flow at same for all layer. A is equal to A1 plus A2 plus A3, means velocity is equal to discharge upon area is equal to as K and E is the same, velocity is the same. V1 is equal to V plus V3. is equal to K into H by L. I is equal to H by L म्हणजे V is equal to K into I. At last H is equal to V into L by K. At last H is equal to V into L by K. Velocity into length upon permeability. Length is height. For layer 1, H1 is equal to V1 H1 upon K1. H2 for layer 2 is equal to H2 is equal to V2 H2 upon K2. For layer 3, H3 is equal to V3 H3 upon K3. For entire soil, H is equal to V is equal to H1 plus H2 plus H. बंद कर ना ढोमना, कोई गरज आहे का बोलायची? The entire soil H1 is equal to V into L upon K average. दोस्तों, डे 3 का फर्स्ट सेशन अभी पूरा हो चुका है। हो सकता है आज आपने बहुत ज़्यादा पढ़ाई नहीं की हो, लेकिन अगर आपने हार नहीं मानी तो आज का दिन सफल हो सकता है। याद रखिए, कोई भी बड़ा सामना एक दिन में पूरा नहीं होता, वह पूरा होता है ऐसे छोटी छोटी दिनों से। अगर आपने आज मेरे साथ पढ़ाई की तो दिल से धन्यवाद। अगर आप भी इस 180 डेज स्टडी चैलेंज का हिस्सा है तो कमेंट में लिखिए डे 3 फर्स्ट सेशन कंप्लीटेड। और अगर अभी तक आपने चैनल सब्सक्राइब नहीं किया है तो VSB ब्लूप्रिंट से जुड़ जाइए। यहाँ कोई फेक मोटिवेशन नहीं, सिर्फ रियल जर्नी, रियल स्ट्रगल और रियल ग्रोथ मिलेगी। याद रखिए, स्मार्ट वर्क दिशा देता है, हार्ड वर्क मंजिल तक पहुंचाता है और कंसिस्टेंसी सपनों को हकीकत बनाती है। हम गांव से आए हैं लेकिन सफलता की मंजिल तक सबको साथ लेकर जाएंगे। मैं हूँ विश्वराज, मिलते हैं डे 3 सेकंड सेशन में। तब तक पढ़ते रहिए, बढ़ते रहिए। जय हिंद।